everyone, my name is Hannah Jean Marcelo.
Hi, my name is Rizal Estado.
Hi, I'm Anjanette Atienza.
I'm Ferdinand Atibacos.
Now,
We will teach you
How Newton's Raphson
Raphson'S method works.
Newton's Raphson method is also known as Newton's method, is a way to quickly find a good approximation for the root of a real valued function. F of x equals 0. It uses the idea that a continuous and differentiable function can be approximated by a straight line tangent to it. How it works? Suppose you need to find the root of you are looking for. Is new, the point is x equals x sub 0. The Newton method tells us that a better approximation for the root is x sub 1 equals x sub 0 minus f of x sub 0 over f prime of x sub 0. This process may be repeated as many as necessary to get the desired accuracy in general for any x value. X sub n, the next value is given by x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n.
So, in this method, the given example is f of x equals 2 cosine x minus e raised to x equals 0. So first, what we are going to do is to differentiate the f of x to find our f prime of x. So we will have f prime of x equals negative 2 sine x minus e raised to x. The second step is to choose an initial guess. We will have to guess a value for x to start with. So now we're going to use a table. Substitute the value of x to the given equation. So since this is a continuous function, at some point it has to cross 0. X value has to be somewhere between 0 and 1. This will help us to get more accurate 0 or accurate solution. And as we can see, and as we all know, 0.719 is much closer to 0. We will use a value of 1 for our first iteration or to start with.
the given formula is x sub n plus 1 equal to x sub n minus f of x sub I over f prime of x sub I, where x sub I equal to x sub n. Since 1 is our first iteration, we will write it down on the table and the other value, x sub n as new iteration, x sub I as old iteration. X sub n equal to 1 minus negative 0.719 over negative 2.753 equal to 0.739. Substitute 0.739 to get f of x, f prime of x. Then plug in the values into a given formula. We will have 0.695. Repeat the step. 0.693 will be our new iteration. Repeat the step. We got 1.481 times 10 raised to negative 4 or 0.000. In this case, we could say that this is approximately 0. That's how can use Newton-Raphson method to solve function.
there is a quicker way that you could work these calculations. First, you should have a scientific calculator with ANS, X-rays, and fraction button. All you can do is you type the first iteration, in this case, 1, in the cycle, and then press equal buttons. 1 becomes the answer. Then clear the value by pressing AC button so the screen will clear. And 1 is stored in this value here in ANS. Next, type in this particular formula. Only we need to replace x sub I with answer. Just hit the ANS key and you should get ANS come up on the screen and then minus. Press the fraction button on your cycle. Then enter f of x sub I. And in this case, it will be 2 cosine, the answer, minus e raised to answer. To get e, just press alpha. Then press x10. And then we divide this all by f prime x sub I equals minus 2 sine the answer minus e raised to answer. When you press equals, it's passing your first value for answer, which was 1, through this equation here. And you should find when you press the equals, you get 0.739. And if you press equals again, you'll get the next approximation, 0.695, and so on. This technique saves a lot of time if you can do this.
In my right car, business change, and I like I ain't all this.